So it's easy to generate particles just growing if we create an emitter. Just do a simple omni emitter with a little bit of speed. And I'll just put it in the middle of the world here and raise it up a little bit in the nucleus node. Yep, I just turned it on. Yeah. And so in the middle of the world, just above the floor, and then in the nucleus node, if we want to, we can turn on use plane, so it'll just simulate a floor here. Make sure I'm on play every frame. Yep. And I'll give myself some more frames to work with. So now if I play the animation, particles are born and they spread out. If I want them to not move so far, to make a little growing pile, then in the end particle shape itself, we can turn on something like damp just a little bit. So this is under the dynamic properties. Maybe a little. Oh, that didn't take. Got to return. So with damp on, they kind of don't move out quite so far. I can turn that up a little bit. So here we can have just like a little growing tumor here. And so, which is good, it makes a little pile that grows, and we can skin this with a mesh, and we'll do that later on. But you can see that the point of origin is always that central emitter, which is not really what we want. What we want to have happen is have these particles, if this was a new particle born, that it could be randomly selected and then split into two, or at least appear to split into two. We're also going to skin this thing, and just so we'll come back to this in a minute, but if you select particles and go to modify, convert end particle to polygon, it will generate a mesh that you can apply materials to and render, and it will grow with the object. You can see it's not dynamic itself because it's actually passing through that floor plane. It's just generated from those dynamic objects. Okay, so let's go back to the file that we had just a minute ago, and we'll see how that one works. And then we'll rebuild it. Oh, that's right. So we start with just a single particle, and if we look in the outliner, it's a very simple scene. It's just the nucleus node and the this is called BACT, or bacteria or something, particle shape. And it starts with just a single particle. So I created this just by, well, we'll look at that in a sec. Let's just play it again and watch what happens. We'll watch the timeline too, because we use the frame number as a random number generator to occasionally have this thing do something. Okay, it's very Smurfy. So let's look at what's happening here. There's no emitter because I created this particle just by using my end particle tool, just using the sketch particle and just clicking and hitting enter to generate a new particle system. So there's actually no emitter associated with this particle at all. There are no fields in the scene. The only thing driving what's happening here are expressions. So if we look at the attribute editor here for this particle shape, most of the action is happening here in the per particle array attributes. So when we want to use per particle arrays, because we don't want to have things happen on a global setting for this group of particles, but we want to have individual things happening to individual particles at different times. So we'll go in here and just look, and then we'll rebuild it step by step. So if we want to look at what's going on in here under position, there's an indicator that there's something here. These things like the radius pp, so radius per particle, opacity per particle, these are connected to ramps. You can see the ramp listed here. And those are these things up here, these built-in ramps um, in the particle shape node. If you want to get rid of that, you can just right-click and go to break connection if we want to write a code to do, or an expression to control that. Or we can just leave that alone for now. If we right-click here in the position attribute, we can go to one of these. I forget where I wrote it. It's a runtime before dynamics. So let's just look at what's going on here. So generally when you write an expression, and mine's a little bit messy here, but you declare the variables that you need. No, I don't need this one. So here I'm declaring a variable called $ID for, it can be called anything, but I call it something sort of sensible. And I'm gathering data about the particles, the particle ID. Each particle has its own number when it's born. And because I'm just gathering numbers, I just need an integer type variable. So this would be 0, 1, 2, 3, and so on. Then I want to gather some information about the position of each particle. Because I want to know, so if this particle is here, and then it splits and there are two new particles, I want new particles to be born from one of these two spaces now. So I have to gather information about each particle's position in space. And so I'm gathering that information in a vector variable. So it's got three values, in this case x, y, and z. And I'm calling it $POS. And the value that I'm gathering here is an existing attribute called the node's position attribute. And I'm creating another variable, because think of what's happening here. We've got a particle, and then it's splitting, and the two particles are pushing away in opposite directions. So they have to have velocity. They've got to be moving somehow. So now I'm declaring a new variable. It's a vector, so it's got x, y, z value. And I'm calling it $vel, because it's going to contain my velocity information. But it's not gathering existing velocity information. It's putting value in here. Right now it has nothing to do with velocity, except I know that I'm going to apply it to the velocity of the particles. And so this is an interesting command, sfrand. It's a random number generator. But the way it works, so it's very similar to an expression we've seen before, which is just random. So if you want to generate a random number in Maya, it's just rand, and you can type, let's say, between 0 and 500. So that's the command, and those are the two arguments. So it's going to do the first number and the second number contain your randomization. So it could be any number here, 10 or 500. If you just put in a single number like 360, it'll generate a random number between 0 and 360. Okay, so that's what rand is. Sfrand is a little different. It's generating a random number, but you have to imagine a sphere in 3D space, so that's not a circle, but a sphere. And it's got a center, and so it's got a radius as well, right? So you've got R here. And so when you do a sfrand command, and you put bracket 3, it's going to generate a sphere that has a radius of 3. So you can change that. And what it does randomly is pick a space, a point in the 3D space within the sphere. So when it does that, so let's say it picks, it's hard to visualize this in 3D on the medium, but let's say it picks this space here. So it's going to have a relative position from the center with an x, y, z value. So it's got a direction that it's pointing from here, but it's also got a magnitude, right? So it's got a length of this arrow. So we can use that for velocity. because it's got directionality and then it's got magnitude, so how much it's going to push it. So if we're using a strand of 3, it can pick from this bigger area and it can pick farther out. And so it can have more magnitude to push the particle out. If it's a strand of 1, let's say, a strand of 1, let's say, then we're going to have a smaller sphere, and so it's going to only choose smaller magnitude vectors. So it's just really a way to pick a random vector. Okay. What's the question?
Are you recording this?
Yeah. And so, and then I need just a general random number generator, because I'm going to use that later on. So this random number generator is an integer, so this is just a new variable, it's an integer variable called $rn, and I'm filling it with a value, a random number between 0 and 100. And that's generated on every frame. So all of these expressions are in this part of my expression editor called runtime before dynamics. It could be in after dynamics, but as long as it's runtime, it means that we'll run through this whole thing on every frame. So every frame, a new random number will be generated. Okay? So the next thing that happens is I ask something of the scene. So I say that if the random number that's generated is equivalent to the particle ID, so let's say the random number generated is 54 and there's a particle 54 existing in the scene at that point, which I've already gathered up here, then I'm going to run this expression because there's an if statement here. And so if this is true, and I'll just bring your attention to this double equal sign means you're asking a question about the variable. So you're asking something about the data in there. If it's just a single equal sign, it means you're declaring something about the variable. You're putting information in it, essentially. So if this turns out to be true, if that random number equals an existing particle ID, and this separates the question from the answer, then this will happen. Lifespan pp equals 0. Just for that one particle that was identified, okay? And that means if it has a lifespan of 0, it'll die. It'll just disappear. And then we're running another command. So here's a new command, emit. So we don't have an emitter, but we have an emit command that we can call. So we're going to emit a new particle, and then here's our first flag. This is the object flag. So this means what particle shape do we want to emit that particle into. And in this case, we want to emit it back into itself. So the first particle, number 54, dies, disappears, and then we've got 2 emit commands. So 2 new particles will be generated in that same particle shape. Right? That'll be important later on when we generate that mesh. We don't want to generate new particle shapes each time new particles are created. So we want to emit it back into that original particle shape. And then here's a new flag that's associated with the emit command. We want to give a position for where that particle will be born. And so we gathered that information before, the $POS. And because it was a vector, we can actually call its individual values in the x, y, and z values, just by saying, giving the name of the variable and then .x, y, and z. So the new particle is born, it's put into the same shape, and then it's given the same position as the particle that just died, right? And that's done twice here. So 2 particles are born, exactly in the same position. And then we're giving one more attribute. So AT is an attribute that we want to add to this. And in this case, we want to add velocity. So this is a built-in argument. So the command is emit, and then we're adding this argument velocity. We have to have this other flag. This is called a vector variable. So we're saying add the attribute velocity to this new particle, and we have to define it with a vector variable. So this setup is just predefined, and I'll show you where this information is in the myhelp. And then we're giving it a velocity. So that vel x, vel y, and vel z. Remember, that's gathered from the strand random number. And you can see that this one up here is negative, and the other particle that's created is positive. So they'll have the same number, but they'll push in opposite directions. So if it's given a vector of 1, 1, 4, 7, this will be -1, -4, -7, and they'll be pushed in opposite directions. Oops. And then we also, and so that ends the if statement. And we have another if statement here, just saying that if velocity happens to be 0, if it has nothing in there, if we just happen to get a strand value of 0, then it's just going to add these values. This probably wouldn't matter, but just in case. Actually, I don't even know if this is doing anything. I'm going to try and take it out and see if it does anything. So I'm just going to copy this, and let's try and build this again. And then before we do that, let's just look at this particle to see what sort of attributes I have set on the particle itself. So I have self-collide turned off because that was causing some problems of making them push away from each other too quickly. It introduces some other problems in that they can intersect again in the future, but it seems to be working okay. So self-collide is turned off. Everything else is kind of standard here. I have a little bit of drag, but it's on by default. And everything else is pretty normal. So let me just copy and paste this into this thing so we can go in, and let's just build this again. So we'll type all this out together. So I'm going to create a new file here. And so we want to create just a single particle, so we can just use our particle tool. We don't want to make a grid this time, we just want to sketch particles. I'm just going to click once in the middle of the world here and hit return, and we'll get our particle. I'm going to give it make it a little bit bigger. So the particle size by default is 0.2. I'm going to just try and make it 0.5. Give myself some more frames to work with here. So if I play the animation now, it'll just fall away. So we don't want gravity to be working here, so we can just select the particle, and under the dynamic properties, we can just say ignore solver gravity here. That's in the particle shape node. So now if we play, nothing will happen. So let's write that expression one piece at a time. So you can right-click in any of these areas here. Doesn't matter, they all lead to the same place. But we can just right-click in position and do a runtime expression. Either one, doesn't matter. And it'll open up your expression editor. So here we're going to start setting our variables. Let's see if I can do it from memory. So first we need to set a vector. I'll make this bigger. A vector variable. So you're defining the variable first. It always has to be named first with a $sign, and we'll call this POS. That's sort of common in MEL coding. The variable for position you call POS. So we see that. and this is going to equal position. And you always have to end your statements with a semicolon. And you can test to see if it worked by pressing create at the bottom of the expression editor. And if it doesn't turn red down here in the warning line, then you're fine. Okay, so now we're going to, what else do we have to create? We need one for particle ID. So particle ID is an integer, and we'll call this one just ID. You can call it anything, it doesn't matter, but it makes it worthwhile to name these things sensibly. And we can just call the value particle ID, I think it's with a capital I, particle ID ended with a semicolon. Click edit, I didn't get a warning, so that must be good. And then we're going to define a vector for our velocity. So vel, and we'll say sprand, S-P-H-R-A-N-D. And this time, so you can do any value, try 2. Hit edit. After you create the first statement, the create button turns to edit. So click on edit to finalize this to see if there are any problems. And there aren't. So now we need our random number generator. So this will be an integer. And I call this Rn for random number. And this will just equal a random value between 0 and, let's say 500 this time. So if it's 500, it'll come up less often, so the divisions will happen less frequently. End it with a semicolon, edit. If you ever want to make notes for yourself in an expression, and it's usually worthwhile, because you'll come back to it and not remember what you're trying to do, you can just comment it out by //. And so you can say declaring variables, something like that. And so this doesn't run. Maya recognizes the // as a line that should be ignored. So then we can do another one, testing frame, something like that. Or no, we're not doing it with frame on this one. We're just testing random number. So there's another way that I was doing it where if the random number equals the frame number you hit, then the particle of that number will split. So there are always different ways of doing these random number generators and tests. So we want to say if. So an if statement starts with if. Always has to have the question in a bracket. So if Rn, so our random number, is equivalent to, so double equals, $ID, the particle ID, close bracket. Now this is the one case where you don't put a semicolon, because we're actually not finished our expression yet. But you can hit return, and you have to do an open curly bracket above the square bracket. And I only put a tab in here. You don't have to put a tab in, but just to separate out the statement. So if that happens, lifespan pp equals 0. And now I need a semicolon. And return and put a closed curly bracket. So I'll click on edit. I don't get a warning. And so let's see what happens so far. So we just have one particle, so there's only one chance in 500 on each frame that we're going to hit it and kill it. But the first thing we have to do before we do that is by default, particles live forever. Their lifespan is infinite. So if we go up right to the top of our particle shape node, there's lifespan. We have to change the lifespan mode to lifespan pp only. So right now, it'll live forever until it's told to die. Let's play the animation and just see if I can kill it. attention. Okay, so it hit that number somewhere around 720 frames. So we killed it, so we know it works. If we want to have this more likely to happen, we can go back into the expression editor and change that random number generator from between 0 and 5 rather than 500. And it will almost certainly happen nearly right away. Yeah, so it's dead already. So I'll just change this back to a kind of high number, 200. Is everybody okay so far? Following along? Okay. So inside of these curly brackets, we can call some other commands, and that was where the emit command comes in. So we're going to say emit. So that's the command to emit a new particle. And the first flag we'll use is O for object, and we want to emit it into the same particle. And this particle is called n particle shape 1, which is probably what yours is called too. N particle shape 1. And of course the capitalizations all matter, so capital P, capital S. And then we have to tell it where it should be born. So the flag POS, I think it's POS. Yeah. And then we want to gather that information about that particle that just died. And we already know that it's POS.x. Oh, I need the dollar signs in there to call that variable. POS.y, close bracket, then open bracket, POS.z, close bracket. And we want this thing to have a little bit of velocity. So here we're going to call a new attribute, add a new attribute to this new particle, give it some velocity. And it's a vector variable, so we have to have a flag for that vector variable, VV. And we'll use the numbers that we generated earlier. So $vel.x, oops, $vel.y, and these are all in brackets, $vel.z, and end it with a semicolon. Click edit, see if I made mistakes. So I made a mistake somewhere.
You can put a dollar sign before position.
Oh yeah, I did that on purpose to see if you're paying attention. Good work. Go Iowa.
Yes.
So now I've got the random number generator between 0 and 200, so let's see what happens. Will it hit? Will Iowa win? Oh, there it goes. So it died, it happened twice. Why did another one get born there? That's interesting. Okay, it's acting strangely already. So let's run it again, see if we get different results. Yeah. So that one, the first one died and another one was born. That second one died and then a third one was born. Okay, so if we go in and change our strand value to something rather than 2, if I change it to 20, let's see the difference here. Come on. Oh, see, there it goes. And it goes shooting off into the distance. So 20 is too high. So we can leave it at 2 and see what happens. So just before we go on, let's look in under the help files for the Maya script reference, the mel command reference here. This is handy. Oh, let me close my email. So we're using that emit function or command, so we can just search for that here under E. So emit. And so this looks very technical, but once you start working on it, most of them have a pretty good description of what they do. And then they give you a list of all the flags that are associated with it. So there's object, position, here's the attribute. I added the velocity attribute, vector VV, or vector value VV. And then they'll often give a few examples down here. So I think there's one here with, attribute, velocity, vector value, 1, 2, 3. So that's where I got that from. Okay, but we want two particles to be generated here, one going in the opposite direction. So we'll just copy this line, paste that here, and then just make those velocity values negative, just by putting a negative in front of the x, y, z. And let's reduce our random number a little bit, so it'll happen more often, to between 0 and 100. So then we have the, now once we get past, once the particle's numbers exceed 100 or 200 or whatever it was, those ones will never get chosen for division. So there might actually be better ways to do this. I'm not sure about picking that random number, but you can see it starts to sort of organically fill up the space. Now one thing I'm going to do is turn off self-collide, I think. I'm not sure I did that already. Execution error, that sounds bad. So I just turned off self-collide to see if they move away from each other a little more gradually. That's a little better. They move a little too far from each other, so we could do a global setting, not on the per particle, but just add a little bit of damp. That will just dampen the movements of all the particles, and that's in the dynamic properties. Oh, it's too much, I guess. That's kind of a nice growth pattern too if you want a tighter sort of mass growing. That still seems like too low. I'm going to put that back to 0 and just see if it works better with drag rather than damp. So I'll turn up drag and see what that does. Kind of the same thing. Too high. That's better. That's just with a little extra drag. Okay? Is yours not working? What's happening? So what warning are you getting? In the red side for the expression.
Ever since I had
Usually it tells you to syntax. So variables.
this color.
Oh, that's right. Spell wrong. Oh, there you go. It went fine, but your strand is too high. It's at 20. Not working? Let's see.
This keeps on saying I have an error with this.
I just. So testing your. So. This should semicolon. So yeah, even little things like that will derail the whole process. There. Looks like it didn't kill it though. So, oh, I think it generated to the same particle shape. Or into a different particle shape. So alright, so you've got live forever turned on, so you just have to change it to like spin PP in the particle itself. So let's change this to 15, so we'll have to so every time you make a change, you have to click edit. Oops. Yours working? What? Can I look? So let's just reduce this here a little bit. So let's see. So you're not getting an error, so it should work. It's not. It'd be unfair. Oh, something happened. Should work. Everything is correct. Oh, so put in the creation node. So that means it only runs once at the beginning. So we'll just cut this. Bring this and bring it to a runtime. So now we've gone past 10. So this. Wait, so that's right. Let's turn left. Anybody else not working? Yours working good? So yours is also in the creation area. So you've got to copy this. And it has to be in the runtime. So it runs every frame. Because the creation node will just run one run. What run once when the particles are first created. But it has to be tested on every frame. So we'll just get into the creation mode. And I don't think they'll be killed. Oh yes. Yeah. Go to it. Here. Is yours working now?
Mine works fine.
Yours is working?
Yeah.
Probably because where are those particles? I'm just changing the name, that's why. So, these ones?
Yeah.
Oh, it's
Also, the version that we got from the sample file is way better
what we were doing before.
than what we made.
That's right. Okay, that's not the right name. There's a lot of extra chunky. Oh, okay. This is not the name anymore. It's all this.
Wonder why wasn't
Well, because it could. Okay. Do something.
See, that's why I didn't go with this, because it seems so unpredictable to me. There's something popping out everywhere. That's why I was wondering if you did to yours, because it looked like the same French.
This is the big difference.
Yeah.
So, why? Are there other collision things in here?
So these are passive colliders, but that's it.
So, and what's this thing?
It's just a foot. It's a geometry.
Is it a passive collider?
Happens.
Okay, well, we'll have to come back and look at this because it's working. It's just
Yeah.
in the C.
Actually, you can't show it off the expression and get something.
Yeah, so you just want to right click your position and do a run, either one of these run times,
Okay.
and then you can just type it in here. Do you have it's okay, yeah, try. Is yours working? Oh yeah. Is it killing the original ones? Do you have lifespan PP? about the animation. So, go to the top. Okay. Next. Let's see.
I know.
Okay. So one thing that seems to be making it less poppy is having self-collide turned off. But let's try and turn self-collide back on, but change the self-collide width scale. So right now they bump into each other exactly on their outer edges of the sphere. But if we reduce this to a lower value, I don't know what's going to happen. I'm curious to see if it is poppy. So I've changed the self-collide width value to 0.5. That's not bad. But they'll still push each other out of the way a little bit when they bump into each other afterwards. Another way you can achieve this if you want self-collide turned off, and this is a kind of finicky, but you can put a radial field on this particle. So a radial field pushes the particle away from a single point in space. So if we just select the particle and go to fields and select a radial field, I'm just going to reset the settings here. So the only thing you really need to change, I think, I'm going to call this pusher. I think the radial type has to be number 1 rather than 0. That's the way it falls. It has something to do with the way it falls off over space, I think. And these particles are about a unit wide. So we want the attenuation to be, I think 1 would work, because that's the fall off over space from where the thing is. And then the max distance, so that's how far the effect is. So we can set this to 0.5, because the particles are 1 unit wide, I think, in my case anyway. And so the max distance, we just want to reach out from the center, 0.5. I think that's what we want. So now we've got this field that's working on this particle shape, but it's only working from the center of the world here, which happens to be where this first particle is. But we can also have the particles themselves emitting that field. So if we select the particle and the field together, in the fields menu, we can say use selected as source. That means each particle that's created will be emitting that radial field and pushing its neighbors away from itself. So we have self-collide turned off, and I don't know how this will work actually. Oh, there's one thing you do have to turn on, and there's no reason why anybody would ever know this, but in the field, there's a thing that says apply per vertex. That always has to be turned on when you're working with these particles. So apply per vertex in any field, you want to have that turned on. Let's see. So I think they're pushing away from each other. So I'm just going to turn that off now. So that's a magnitude of 5. Turn that off and see if we get the same animation. They're not pushing as far apart from each other now. So we can try different magnitudes on that field. I'll try 10. So this will just, with self-collide turned off, this will still help to keep them separate from each other. This is an old workaround that we used to use before there were particle collisions. It doesn't work perfectly, but it works all right. So the last thing we want to do, unless we just want to render out particles, which we can, or you can put instance geometry on these or whatever, or we can skin these with an output mesh. So if we select the particles and go to Modify, Convert, and Particles to Polygons, like we did before, we'll get this output mesh. It's kind of ugly. But if we go back into our particle shape, where's my... So when you convert a particle to a mesh, the actual particle shape disappears. If I go into form mode, you can see it's not in there anymore. And it's actually kind of a pain when it does this. But if you want to find it, you can open up the node editor under Window. And if you map out the connections for the particle, you'll find the shape node and particle shape node. It's going to make this a little smaller. And then in that shape node, in the attribute editor, way down at the bottom, under Object Display, when you use a particle to create something else, it starts treating the particle like an intermediate object, assuming you don't want to render it. Which is true in this case, we don't want to render it, but it also makes it unselectable. So you can just turn off intermediate object and the particle will come back. So now that we've got it selected, we can go up into the output mesh settings. This is in the particle shape. So there are these output mesh settings somewhere up here. And you can change the quality of the mesh that's produced. So threshold is how close particles have to be before a mesh is created, or how many are overlapping. So the higher the threshold, the less likely you are to get mesh generated. Blobby radius scale is just a magnifier of the size. So we'll make it blobbier. And then mesh triangle size, if you make it smaller, you can have more refined shapes because it can be built with smaller triangles. And if you make it small enough, it'll just sort of encompass the individual particles until they get close to another one. Triangle mesh is terrible, so quad mesh is usually better, and just turn up the smooths. And so now if we play the animation, I'm going to save this before it crashes. I didn't set my... So we can get this kind of blebbing. There is kind of a problem because when they get close to their neighbors, they bleb back together. So it just depends what kind of look you're going for. If they can't bleb back together, you either have to keep them farther apart from each other, or you have to render it some way without the mesh. One thing you could do, I suppose, to change this, if you wanted just each one to have its own mesh, if you select the particle and then go to the expression editor, your animation editor. Instead of emitting those two new particles into the original particle shape, we have them generate a new particle shape. But then you'd end up having probably hundreds of particle shapes, but each one could be generating its own mesh. So you could put a variable in here that creates a new particle shape based on the ID of the particles or something like that. But if you did generation after generation of these, you might end up with 50 or 60 particle shapes. But if each one is generating its own output mesh to make them bleb off from each other, output meshes from different particle shapes can't intersect with each other. So if you only needed like 5 generations of this, you could probably get away with doing that. Actually, that only occurred to me now. So. Okay, so we learned a little bit about different types of variables here and how to apply them in probably the most used type of statement, an if statement. Something about lifespan pp, setting the position, velocity, things like that. There's no, if you're interested in learning this stuff more, read that book, Mel Scripting for Maya Animators, or whatever it's called. It's a great book, kind of out of date, but all this Mel stuff still works. You can do Python scripting in Maya too, but I have no idea. Do you guys do Python? Python? Little Python. Go playing Python scripter.
You have all the dollar signs in there, it's very convenient.
Why?
Well, it's just like you go and declare a variable, just do variable, whatever.
Is this better or worse? Is it inconvenient or convenient?
It's kind of the same.
Yeah. The thing with the Mel scripting is that the whole Maya interface is written in Mel script. And every action that happens in Maya is written in Mel script. So you can figure things out by examining what Maya is doing itself. Let me just open up one last file if I have it here. Oh, maybe I don't. Oh, I think I did on my other computer. Okay, that's enough. Anyway. We can look at another one another time, but there's just a simple expression you can make that when a particle hits a certain object, it can do different things. It can change color, it can change size, change. I don't think it can change instance, but it can do all sorts of things. But we can come back to that later on. Okay, so that's all I've got for today. Is there any questions or anything you want me to go over up front here? Otherwise, I can come around and see if people.
Did you try instancing geometry tables?
Yeah, so you could always instance geometry to this. So if we just create something obvious, just like a torus, make it a little bit smaller. These transformations. So if we select that and just go to particles instancer, it's going to select the P torus is the only thing in the scene. There's only one particle shape in the scene, so it'll apply it to this. We can create that. So now if we and then you could do all the stuff that we did before just to randomize, the rotation of this kind of thing. So if we just go in, so this is a creation expression. We can say rot pp equals rand 360. So rot pp is nothing. It's a per particle attribute. It's not a variable. It's an attribute. It's one that we haven't actually created yet. So if I say create, Maya is going to give me a problem saying there's nothing called rot pp. So I'll go into the particle and create an attribute called rot pp rather than a variable. So under the per particle expressions, add dynamic attributes, general, and we'll just create one called rot pp. This is a per particle array, and it's a vector because it's got x, y, and z values. Say OK. So now we'll just do that again. Rot pp equals rand 360. I think should work. So we've just declared a value for this rot pp, which should be in here somewhere. Usually if it doesn't show up, you have to deselect the particles and reselect them. Yeah, there it is now, rot pp. But then we have to pass that information on to the instances. So under the instance or geometry, this is still in the particle node. I think it's rotation we have to change. I can't remember. And if you don't see the one you created, you have to just go up here, turn on allow all data types. And we should see. Oh, no, still not. Maybe it's not rotation, aim direction. What am I doing wrong? Hold on a second.
Did you need to give it 3 values? This was a vector.
Usually if I'm remembering correctly, it will just copy all 3 of those, but you may rate. So we'll do rand 360, comma, no, it doesn't like that. Am I doing it wrong? Oh, it has to have. Oh, I don't need that rand. So now, will it let me do that? No. I'm being dumb about something. I can't think of what it is. Oh, it's not showing me the instancer node here. There's something screwy. Oh, there it is. Okay, now we got rot pp. I don't know. For some reason, it wasn't. That instancer node wasn't showing up here until I went and selected it. So now, if you wanted to, you could probably tie that rotation to the velocity somehow. But I don't know. That would take a little more thought. But yeah, so you can do it with instances too. And you could also do it randomly selecting among instances like we did with the red blood cells, white blood cells, and platelets before. Anything else anybody wants me to go over? Yeah? Nope. Okay.